Hello and welcome to the updated probabilistic snowfall forecast presentation. Today we'll talk about some slight modifications that have been made to the winter weather forecast provided by the National Weather Service, focusing on the probabilistic snowfall information that we provide. All of the probabilistic snowfall forecasts, as well as the expected forecast snowfall, is available at weather.gov/AKQ/winter. So just a reminder, what is probabilistic snowfall? We produce a series of graphics and data that really allows key decision makers a better idea of the range of expectations when it comes to snowfall and snowstorms. The probabilities are based on National Weather Service official storm total snow forecast. We leverage around 46 numerical models, which we'll show briefly, and this allows us to create a low end, or at least a best case scenario, a high-end worst-case forecast, and then of course also provide you our expected snowfall or most likely outcome. In addition, we are also continuing to provide the chance of exceeding different accumulations of snowfall. This includes a trace of snow, 1 inch, 2 inches, 4 inches, 6 inches, and on up. And we'll show examples of this as we go. So just kind of a brief overview, a reminder how probabilistic snowfall is generated. We start with our core forecast. We coordinate with the Weather Prediction Center. We look at from the national perspective, we localize a snowfall forecast, and then we develop what we consider to be the most likely snowfall prediction. Our actual snowfall prediction is then compared against various weather models and ensembles, about 46 different models and members of different ensembles. What happens then is you have a probabilistic distribution of scenarios. And so our forecast, our expected forecast, actually adjusts and sets the mode of the statistical distribution. This kind of redefines what we call the probabilistic distribution function. So basically what happens is that statistically we look at a wide range and host of different possible snow outcomes across the region. Our exact forecast then adjusts that statistical probability slightly, and then from that falls out the worst case, the low end, as well as all the individual snow probabilities. So it is based on a balancing of our forecast at the National Weather Service combined with statistical outcomes from all the different weather models that are run and put into probabilistic snowfall. To give you an idea of how this works, the 90th percent of all solutions is considered what we can call the worst case scenario, or the high end amount. By this we mean we're taking into account 90% of all probabilities, and it's very unlikely that the snowfall will exceed that amount. The middle of the distribution, or the peak of the statistical distribution, is typically our expected forecast. So if we're forecasting around, let's say, 4 inches of snow, the probability of 4 inches is right in that peak of that bell curve that you saw earlier, which is the 50th percentile. When you get down on the low end, at the 10% exceedance, or 10% probability, what that means is that you can expect at least that much. That is the very, very low end of the statistical distribution. So that's the minimum amount statistically that's expected, with the high end amount being the 90th percentile. And our forecast sits right in the middle, right about the 50th percentile. This gives you an idea of the different model members that go into the probabilistic distribution. So when we're creating our statistical database that provides our distribution of probabilities for snow totals, it's based on 6 of the different SREF ARW members. These are randomly selected. This has been pared down from last season. Last season included many more members of the ARW, and because of the model's ability to basically blow up snowfall forecast, not only in the Mid-Atlantic but also across the nation, they kind of pared down the number of the ARW members that are going into the statistical distribution. There are 9 members from the NMB. We have 10 GFS ensemble members, as well as 10 European model members that go into the statistical analysis. The GFS models part of the distribution, as well as the NAM, 4 more ARW high-res models, 2 national blenders, as well as the European, the actual deterministic European, and the GFS S ensemble mean. So what happens is we take all of these models, come up with a statistical distribution, which is then adjusted based on the exact forecast. We also take into consideration the winter weather forecast provided by the Weather Prediction Center. All this together gives us 46 different members in addition to our expected snowfall forecast. So what you end up with is a low-end forecast amount, basically what we consider to be, the 10th percentile, or in this example, say 90% chance that all snowfall will be higher than this. So then this example here, that's basically saying there's zero snowfall. So this is on the very low end of the distribution of expect at least just this much. It's considered a reasonable low-end snowfall amount for the time period. It's based on, again, the computer models and the model simulations. The lower amount is an unlikely scenario. Our expected snowfall forecast is just that. This map on the website will always be the official National Weather Service snowfall forecast in inches during the time period shown. This is determined by National Weather Service forecasters in coordination with other National Weather Service offices and national centers, and this is considered to be the most likely outcome after evaluating all the different models and observed data. The high-end amount, which basically relates into a 1 in 10 chance of the snowfall occurring, this is considered a reasonable uppercase or upper-end snowfall amount. We could say reasonable worst case snowfall amount for that time period shown on the graphic. It's based on, again, all of the 46 different simulations. That's also weighted with our expected snowfall forecast. This high amount is, again, an unlikely scenario with only a 10% chance of actually occurring, meaning that there's only a 10% probability that snowfall amounts will reach that high based on that model run cycle. But it is a good tool sometimes used for planning purposes if you want to know what is the reasonable worst case as far as a high-end snow amount that I might be able to plan on right now. In addition to those exact forecasts and the high-end and the low-end amounts, we also provide a statistical distribution of the probability of receiving different amounts of snowfall. And that's on the probabilistic snowfall page. As you scroll down the page, you come up with these individual accumulation probabilities, anything from a trace of snow on the far upper left all the way up to greater than 18 inches. And so this kind of gives you an idea of maybe where the best probabilities are for different snow amounts. So if you're interested in 4 or 6 inches of snow, if that could be a criteria for you, you can kind of come in here and see what the probability of that much snowfall is and where that might occur based on the National Weather Service official forecast and the model statistical distribution. Further down the page, the winter page, you'll actually find an individual probability for all the cities across the area. You can sort this by county and jurisdiction. So in the county drop down, you could say go in, select something like Chesterfield County or Virginia Beach, and you get all the different local areas within that jurisdiction and the probability at each individual city. So here's an example of how the probabilistic snowfall products performed during the December 8th to 9th snow event, very, very early season snowfall event that happened in 2017. The map you see here is observed snowfall across the region. It was a very heavy, wet snow. On average, most of central Virginia saw anywhere from 3 to 4 inches. There were a few areas there of 5 inches, with over 6 inches over parts of the Maryland Eastern Shore. Looking at the probabilistic snowfall from the Friday morning before the snowfall began, you see here in the upper left-hand corner the 10th percentile, which basically means at least this much. So it tells you 0 inches of snow. So that means that there are some models suggesting that there may actually be no snow and the event could be all rain. The official forecast there is in the middle, forecasting anywhere from 1 to 2 inches, maybe upwards of 2 to 3, which you get maybe on the northwest side of Richmond. The 90th percentile, or the worst case, what you see there is forecasting maybe around Richmond as much as 7 inches, maybe some isolated 8, with maybe 1 to 2 inches reaching all the way down into tidewater. And again, that's a worst case scenario, only a 10% chance of that occurring. The bottom graphics are a little bit more telling and maybe a little bit more useful. The lower left-hand corner, you see the probability of getting at least an inch of snow or more. So you see all across central Virginia and even across Maryland, you're going to get at least an inch of snow. Probability of greater than 2 inches in the middle, Again, very likely, 60% chance across central Virginia, even 60% chance over Maryland Eastern Shore. At this point, the models were still fairly warm, and you see the probability of 4 inches of snow is still pretty significant, 40% chance across most of central Virginia. And you can see that that band of higher probabilities of 40% really runs from the, I'd say, right through Richmond, and especially to the north and the west of Richmond, but not quite to Louisa, and then again up into parts of Maryland. So you kind of have this area of higher probability of 40% or higher that runs across, portions of central Virginia, north and west of Richmond, and then up into the Maryland Eastern Shore. If you go back to see how the snowfall actually distributes itself, you can see that was actually a very good prediction, showing that you had a pretty good probability, at least a 40% chance, of getting a band of 4 inches of snow to set up across central Virginia, oriented up into the Maryland Eastern Shore. So this is the observed snowfall. And again, you look at the bottom right-hand corner, the probability of getting 4 inches or more, and it correlated very, very well, even though official forecast here in the upper center of image was a little bit lower, forecasting snowfall amounts of 1 to 2 inches, maybe upwards of 2 to 3. Again, this was because a number of the models were still fairly warm, producing a lot of a rain, snow, sleet mix across central Virginia. With subsequent forecasts, the snowfall amounts were raised significantly as it looks like the atmosphere was going to be cooler. So this is a neat way to kind of apply the probabilities, again, where you see the official forecast of 1 to 2 inches. But again, the probability of getting 4 inches or more is 40%, maybe a little bit higher than 40%. And that is statistically significant. What that is telling you is that probably more than 1/3 of all the model solutions out there are suggesting at least 4 inches of snow. So again, I would consider that to be statistically significant and maybe something to be aware of and possibly plan for. So let's take a look at a little bigger snow event that occurred back on January 7th of 2017, and how did that play out in the snow probabilities, and how useful would that have been to apply the snow probabilities in a very large snowfall event. Snowfall accumulations with this event were quite large, upwards of 10 inches, even a foot across portions of the Hampton Roads region across the peninsula. Even the Middle Peninsula had upwards of 13 inches. There was a very widespread swath of 6 to 8 inches of snow that really ran from Norfolk and Chesapeake all the way inland west of Richmond. So it's not real common sometimes to see this broad and this large of a swath of over 6 inches of snow. And so let's take a look and see how the probabilities may have been able to inform us that such an event was about to occur. So this was on the afternoon of January 4th, and remember, we'll go back, the snowfall actually occurred January 7th. So this is 3 days prior to the event. The storm system looks like at this point it's going to pass way offshore. A lot of the models are keeping the storm system well off the coast. And you can see our forecast here in the upper middle is forecasting about 4 to 6 inches of snow, and it's across portions of North Carolina and southeast Virginia. And again, that's because the storm system is expected to remain well offshore and to the south. The worst case scenario across parts of North Carolina and southeast Virginia was around 8 to 9 inches of snow. The probability of seeing at least 6 inches of snow, you see a pretty significant probability here of 40% or higher across southeast Virginia and northeast North Carolina. So the models are at least already hinting at the fact that we're probably going to see 6 inches of snow or greater in some areas. Probability of 8 inches of snow, about 20%, so about a 1 in 5 chance. So about 20% of the models are suggesting at least 8 inches of snow. Very few models are suggesting a foot of snow this early on. The next day, there's quite a bit of shift in the distribution and in how the models are handling the storm system. The reason for this is the storm system looks like it's going to track a little bit closer to the coast, a little bit further north, meaning that it's going to push more moisture further inland. So in the middle picture here, our forecast, we're forecasting now a band of 8 to 12 inches of snow. And again, this is 2 days prior to the actual snowfall event. So we're already forecasting a band of 8 to 12 inches of snow across portions of Tidewater, North Carolina, and up to the eastern shore, and a very broad area here in the lighter yellows of 6 to 8 inches of snow that runs from almost southeast of Elizabeth City to not quite Richmond. The worst case scenario is suggesting maybe upwards of 13 to 14 inches of snow, and again, a very broad area, maybe upwards of 7 to 9 inches of snow on the south side of Richmond. So what do the probabilities look like? Probability of 6 inches of snow or greater is over a big area, almost greater than 50 to 60% across all of southeast Virginia and northeast North Carolina. That's telling you that a very large distribution of the weather models, including our forecast, are predicting a very heavy snow event of 6 inches or more. The bottom middle graphic, what's the chance of seeing 8 inches of snow? Again, this is kind of the sweet spot, the middle of the distribution. When you think about that bell curve, the top of the bell curve is around 50%. So you see, a pretty wide swath here of anywhere from 40 to 50% probability of seeing at least 8 inches of snow or more, again, across a very broad, wide area. And that really runs from almost Elizabeth City back past Wakefield and across up the peninsula and the middle peninsula, as well as the eastern shore. The chance of receiving 12 inches of snow has increased compared to the previous day's predictions. And now we're starting to push upwards about maybe about 20% probability, kind of widespread across southeast Virginia and northeast North Carolina. So about a 1 in 5 chance that you're going to see a foot of snow or more. Looking at the forecast on the morning of January 6th, and now the day before the snowfall occurs, you can see our forecast continues to paint kind of a broad area here of 8 to 12 inches of snow, with 6 to 8 inches of snow pushing all the way back to Richmond. One of the things that was a little bit concerning and a little confusing was the worst case snowfall amounts. It took the 12 inches all the way up to Richmond, where the previous forecast kept the 12 inches kind of shunted down across the tidewater in south central Virginia. The worst case scenarios the next day pushed the 12 inches of snow all the way to Richmond. However, if you look at the probability of receiving 12 inches of snow in the graphic here underneath that, you see the best probability of seeing a foot of snow, and we'll say about 20% or greater, is still pretty much confined to portions of the tidewater, the peninsulas, as well as eastern shore, and a little bit down here into northeast North Carolina. The probability of seeing a foot of snow in Richmond is only about 13%, but it jumps up to about 20 to 22% once you get to tidewater and Hampton Roads. So that's about a 10% or greater difference of seeing a foot of snowfall. Now, the probability of 8 inches of snow, again, this kind of shows you how Richmond does have about a 30% chance, about a 1 in 3 chance of seeing maybe 8 inches of snow, which is, I'd say, statistically significant. Basically, that means that in the Richmond area, about 1/3 of all the models are at least saying you could have 8 inches of snow. The rest of the models are forecasting lower amounts. But once you get down, to Petersburg and then all the way down to the Norfolk area, the probability of seeing 8 inches of snow or more really starts to increase quickly to 40, even 60%. So it's still showing you the heaviest snowfall of 8 inches or more should be confined to the south and southeast side of Richmond and then towards the coast, where Richmond may flirt with 8 inches of snow, but the probability is just not as great. Now, the probability of seeing at least 6 inches of snow here on the lower left, even in the Richmond area, you're up to about 42% probability. So a pretty decent probability. You're kind of almost getting into the top of that bell curve. Top of the bell curve represents 50 percentile. So good probability of seeing close to 6 inches. But again, as you push down towards Petersburg and Wakefield and eventually Hampton Roads, you're really definitely going to see probably 6 inches of snow or more. And of course, we're forecasting in those areas anywhere from 6 to upwards of 12 inches of snow in our forecast. So the best way to use this product is to look at our most likely snowfall forecast. You can look at the upper left-hand image there to say, okay, how much do we at least expect? Sometimes that least amount is useful, sometimes it's not. The worst case is just that. It's the absolute worst case. In some cases, it may only be a 10% chance that you're going to see that much snowfall. So when you use those images up here at the top row, you really then need to go down and look at the individual probabilities for each amount of snowfall accumulation. And as you step through the different accumulation amounts, it really starts to paint the picture of how the statistical distribution is setting up in our weather models as well as our forecast, and can kind of help to guide you. And watching these probabilities change over time can give you a sense for how even the weather models and what we're looking at is changing over time. Now, by the afternoon of the 6th, you can see now, especially of the 12 inches of snow, the 12-inch of snow band has actually pulled out of Richmond. The higher probabilities now are really centered in from, I'd say, Hampton Roads to just northwest of Wakefield up the eastern shore. You can see here the probability of receiving 12 inches of snow really has started to zero in, again, on southern parts of Virginia, up across the peninsulas and the eastern shore. The probability of a foot of snow in Richmond has dropped down to 5%. Probability of 8 inches of snow has decreased for Richmond, about maybe a 24% probability of 8 inches. 6 inches of snow in Richmond, though, still about 43%. So significant probability that we could see around 6 inches of snow in Richmond. 8 inches maybe, but the probabilities are better as you go down 95 south of Richmond. And by the time you get across south central Virginia and the Tidewater, 8 inches is probably a sure thing. And even a foot of snow in this scenario is probably fairly likely. And so this does a very good job here of looking at the individual snow probabilities of different snow amounts. Does a very good job trying to zero in what areas are most likely going to see the most amount of snow and where. So again, coupling all these together on the winter website is an absolute great planning tool. So something to note from this case, between the 5th and 6th of January, the probabilities of 6 inches of snow in Norfolk really jumped dramatically. So anytime you see the probabilities jumping up or down, there's probably some significance to that. There's been some very significant statistical shift in the snow probabilities based on a combination of the weather models and most likely our forecast as well. We saw similar shifts over northeast North Carolina, but instead of the snowfall amounts shifting upwards, they actually shifted downwards pretty dramatically. Early on, we had probabilities of a foot of snow pretty high over northeast North Carolina. By the time we got to the afternoon before the event, the probabilities of a foot of snow over northeast North Carolina was down below 10%. One thing that was nice in this event in time as well is as the event got closer, the probabilities did actually start to really confine themselves and really started to zero in on the areas where we were really going to experience the heaviest snowfall the closer we got to the event. And that basically is telling you that the models are coming into a little bit better consensus and a little bit better agreement on how things are going to set up across the region. So again, you can find all of our probabilistic snowfall information at weather.gov/AKQ/winter. We also provide our expected snowfall amounts as well as expected rainfall amounts and ice amounts on our briefing page, weather.gov/AKQ/rain, snow, and winter on the briefing page. If you have any questions or comments regarding the probabilistic snowfall information or this webpage, feel free to email Michael Dutter, Bill Samler, or myself.